So at this point, we've pretty well covered all of the concepts associated with an introduction to hacking and penetration testing. So we're going to take some time to kind of give you some information to introduce yourself to various hacking tools and some of the more popular tools that you might be using, just to get you started in understanding tool usage and some of the capabilities offered there. So we're going to talk about a couple of different very popular tools, starting off with probably the most popular scanning tool, Nmap. We're going to look at some demonstrations there and some different options that might be chosen. We'll also take a look at a Windows port scanner and network scanning utility called Superscan. In addition, we'll take a look at the Nessus Vulnerability Assessment tool and the Metasploit Framework, which is the exploitation version of Nessus, but not quite as robust. So to kick things off, Nmap is probably the most popular flexible hacker tool out there. Versions exist for both the Windows and Linux platforms, as well as just about any other platform out there, even so far as BSD and Macintosh. As a general rule, the Linux command line version actually works a lot better and is even better supported and tends to function and give better results. It has various functions such as ping utilities, port scanning utilities, service enumeration, and OS fingerprinting. All of that is built into a very compact and useful tool. It's extremely useful throughout the process, but it really shines extremely well during the early stages of the attack mechanism. We're going to go in, we're going to scan the network, find the systems that are on the network, and then we're going to use it to enumerate host information and services and fingerprint those operating systems and applications. The command line features actually have a series of switches that indicate what you want to do and what you want to do it against. So it's actually really easy to use, and even if you don't like using the command line, there are Nmap graphical front ends available even for the Linux operating system. So let's dive right in and take a look at an Nmap demonstration. And we're basically going to go over some of the more common tool usage that's available and that you might frequently use. So the first one we're going to look at is the SYN scan. So we're going to type in Nmap. And that's going to initialize a program for us, and then we can type in any switches that we like at this point. So we're going to actually focus in on the default, which is actually the TCP SYN scan. And the SYN scan is going to be the default choice if you don't choose a scanning mechanism. Because it's so very effective, it's very fast, works extremely well, and can scan thousands of ports per second on a relatively fast network. It's pretty silent and stealthy because it never fully establishes a TCP transaction. So at this point, we'll choose our host. And we're going to port that into a text file. And in this example, we're going to call it syn.txt. Okay, so while that's running, we're going to go ahead and open up another shell and kick off a different Nmap scan. And this time, we're actually going to specify the TCP Connect scan, which is used with ST. And the TCP Connect scan has a comparable speed and result set as the SYN scan, but it's very noisy and is easily detected by intrusion detection systems. So it's generally not used, but we'll use it in the place of a SYN scan where the SYN scan's not possible. So if we want to take a quick example of what we've seen so far, we can open up our TCP results. And as you can see here, we actually enumerated quite a bit of information. We can see we have an FTP server, a domain server, a DNS server, web server. All of these different features are built in. And our SYN scan is actually going to be pretty much comparable to that. So if we take a look at our SYN scan, we can see that we got comparable answers, but the SYN is going to be significantly quieter on the network than the TCP scan is going to provide for us. We can also use the UDP scan by specifying SU, and it's going to look for ports that are responding to the UDP protocol as opposed to TCP. UDP scanning can actually be kind of slow sometimes, but in this example, we have lots of services that responded quickly to those. So we can see all of the different services responding to individual UDP requests. We're also going to take a look at something called a Maimon scan, which is specified by using the SM switch. And this is not going to bring back any information necessarily on a Windows box because it utilizes the implementation of the TCP stack in BSD-based operating systems. So we're going to call this bsd.txt. And as you can see, it showed that all 1672 scan ports were closed, even though they're not, because again, we're going to utilize this against a BSD system, not a Windows system. We also have something called the TCP ACK scan, and the ACK scan is actually built because we want to be able to test firewall systems. So this isn't actually effective in any way against a host, so we're going to actually scan my firewall/NAT. We probably won't get much back from it anyway, but you should definitely be aware that the ACK scan is primarily used to enumerate the firewall rule set of how that works. So it's showing unfiltered on all of those ports. So as you can see, depending on how you set this up, you can definitely get very different answers.